right, so example one, expand using the distributive property. And what's going to happen is you're going to see objects. So what you got here is you have 4a squared over b. That's the single object outside the parentheses distributive property talks about. So even though it's got a bunch of stuff going on, 4a squared over b, that's one thing. And then we have our parentheses. Inside the parentheses, we have b to the negative second over a to the fourth. And we have minus 3ba over a squared. Now, when you look at the individual objects, the yellow, the green, and the blue highlights there, you're looking at you want each of those objects to be as simple as possible. Okay, you don't want those to be more complicated than they have to be. And what we're looking for is a single letter of each type to a positive power. If it's like that, such as the yellow, there's 1a to a positive power, there's 1b to a positive power. That's exactly what we're looking for. Looking at the green, b is to a negative power. That's not as simple as it can be. Looking at the blue, there's 2a's. That's not as simple as it can be. So before you actually apply the distributive property, when the directions are to expand, your first priority is to simplify each object individually. Keep the structure of the problem, object and the parentheses object minus object. But each object has to be as simple as possible. I can't make 4a squared over b any simpler, but I'm changing other stuff, so I'm going to bring that down. Looking at the green, the only issue is the negative power. So again, what we're looking for in this step is, are there negative powers? Are there too many of a single letter? Is there a combination of that? And in this case, a negative power. So the a to the fourth is behaving itself. It stays where it's at. The b to the negative second on top belongs in the bottom. And since I've moved everything off the top, then I'm going to put a 1 up there because every fraction has to have a top. If there's stuff on the bottom, it's got to have a top. The other term we got to deal with here is the blue, and we have minus 3ba over a squared. So again, looking at what's the problem is a. So 3 isn't the problem, b isn't the problem. We got too many a's. The highest power of a is on the bottom. That's where a belongs. And we always subtract when we divide. So the bottom power 2 minus the top power 1 makes 1. If you want to put the 1 there for effect, you can. The 1's not necessary to be written. But again, that's what you want to do before you expand. Before you apply the distributive property, you want each object as simple as it can possibly be. Once you get to that point, now it's the distributive property time. We have the outside object being multiplied by the first object, outside object being multiplied by the second object. Multiplication of fractions is what it always has been. Top times top, bottom times bottom. And you'll notice here that there's an a on top and an a on bottom, that kind of stuff. Don't worry about that until after you've multiplied. So just when you're multiplying, keep it simple. Top times top, bottom times bottom. So if I do 4a squared times 1, I just go 4a squared. If I do b to the first times a to the fourth b squared, a to the fourth is what it is. B times b, I'm going to add the powers. Okay. So in the multiplication step, when I'm multiplying top times top, bottom times bottom, if I do get the same letter happening, go ahead and add those powers, because that's how you do that. Same issue here when I'm going to multiply the outside object now times the second object. It's minus because of opposite signs. Again, I'm going to do top times top. And again, if I get the same type of thing, I'll go ahead and multiply them together. 4 times 3 makes 12. A lot of times people want to put 7 there because you're adding powers. But again, this is a multiplication. B times b squared makes b to the third. The rule for multiplying letters says to add powers. 4 times 3 equals 12 because that's what you learned in second grade. Or third grade, whatever grade you learn how to multiply 4 times 3. Okay. A squared times b are different letters, so nothing happens. We can just stick those together. On the bottom, b times a, again, different letters. I just get ab or ba, take your pick. So in the multiplication step, when you're multiplying the outside times the inside pieces, just do a simple top times top, bottom times bottom. Don't worry about the fact that we have same letters on top and bottom. Don't worry about that until after you've done the multiplication. The final step is to compare, look at these objects just the same way we looked at it up here. What we're looking for is positive powers, which we should have positive powers to make that happen. But if we have multiple letters, we need to fix that. So this has too many A's. This has too many A's and too many B's. All right? So we do that, we fix that by subtracting the powers, putting the answer where the bigger power is. So for the red one, I'll do this in red. The 4 is behaving itself, the b cubed is behaving itself. Where does a belong? Very good, on the bottom, because 4 is bigger than 2. And as far as the power, we subtract big minus small. 4 minus 2 makes 2. Looking at the blue term, 12 is behaving itself. Where does a belong? on the top because 2 is bigger than 1. Again, there's always an understood 1 if there's no power written. And we subtract 2 minus 1 makes 1. Where does B belong? It doesn't. B's exactly the same. They cancel. If everything happens to cancel, it's 1. You do have to put minus 1. But in this case, since other stuff didn't cancel, the 1's just irrelevant. You just cross those B's off. In this case, the 12a just ends up being a non-fraction, so we can actually write it as a non-fraction. That's fine. If you put it over 1, it's still right. So take your pick. That's what we're looking for. And that's what expand means. We're going to take a single object times multiple objects. We should end up with multiple terms, usually. There's a sometimes these two guys happen to be like terms. You can add them together. Obviously, they aren't here, so they won't be down here. Okay, but if this was a and this was plus 2a, that makes 3a. That's allowed. You can do like term addition, then multiply. But that's not typical. That happens once out of every 100 or so problems. I wouldn't expect it. This is more typical what you